Okie doke. Let's get the glasses going and get started. Where did we end? Standard arrays, what about them? Compile time. Well. Oh. Really? Oh, the different ways of getting the size. S size, standard size. There's dot size, and then there's standard size, and then standard F size to get a signed version instead of a size T. We get a standard pointer diff T. Makes sense. And then we were saying that even for runtime arrays, because the size is a constant expression value, meaning it's a constant expression, we can get it at compile time even for runtime arrays. And it's because even though the runtime array's value doesn't exist yet, we know that it has a certain size that can't change. Therefore, there's no issue with getting its size later on as a constant expression value. Too fucking hot. Why that's helpful, I'm not sure yet. Well, I mean, I guess the point is just to optimize things. So if we know that the length of a standard vector is something, and it can't change, then anything that depends on it could be ran at compile time. So it's just one value, one variable basically, that is known at compile time, which might enable other things to use that at compile time. Like in a const eval function. Like, right? I mean, wouldn't this make sense? Even though it's const eval, we can get this guy at compile time. Versus, oh, and that's not standard vector, that should be standard array. I'll just correct that first. Fuck it, I'll just delete the line. It doesn't work. Why? Because this guy is a standard vector, not a standard array. And this guy's size can change versus a standard array that cannot. Okay. Shouldn't do that, I should be rubbing up here. Apparently it's better for your eyes. Hold on, I got tears in my eyes. Okay. Getting the length as a const expression value. Yep. even when it's non const expression, because we know it's a non-typed input parameter, so we know that it has to be known at compile time. Oh, true. Or you could just create a variable or a value that's known at compile time, and it includes a function call because the function is evaluating at compile time. Okay. Trying to think of examples here. Does this? Oh. There's a standard array, and we're using compile time, or class template argument deduction for the type and length, and then we are. What's the issue it's having? What the line it's having an issue with is here. So it doesn't like standard size, but what if it was array.size? Oh, even then, really? So it's fine. What the fuck is happening here? Is it because we haven't passed it at compile time? Still? Is it because it's an int? Hold. What is the issue here? Standard array, size 5 in integers. So that doesn't work yet. Nothing yet. Still has an issue. What happened earlier? Is it? Oh. It's because of this conversion here. It doesn't want to be converted to that. Okay. Versus before, I had it as a standard size t there. Okay. So it's not treating this as a compile time, the length as a compile time value to initialize this guy. Okay. Excuse me. Ugh. It's under consideration for 2 years. Oh, great. Due to a language defect, the above functions return a non-const expression value when called on a standard array. Yo. What is the syntax? Put this here. These meaning that when we're using a const reference for it, the functions can't execute at compile time because there's no way for them to return. Well, anyways, this wouldn't work at compile time because we're using standard character output, which doesn't exist until runtime. Or at least it prevents these functions from evaluating to a constant every time. Oh, this is good. Why are there so many dislikes? Makes no sense. Because it can't evaluate to a constant? The point here is the conversion. Okay. But I don't know why this would fix it, because if this is a compile time value, we already know that this is a compile time value. So why does passing it there work? Does it just not care about narrowing when we're passing things to non-type template parameters? I guess so. So we could use operator, subscript operator, or the at. Well, yeah, because otherwise, if we compile, no error. We run, finally, error, and it stops the program. We want to handle it earlier than the program. Ideally at compile time, so that the error can't happen. So what, are we calling it a function? An operator overload function or what? I don't see s size here. I only see .at in subscript. I don't know if it gets bigger than size t anyway, so I don't think it could be narrowing. You call it with a cost expression value. It does this shit at compile time to create a standard size t. Oh, and the point is, it's not forgot size t is unsigned, and that's where the narrowing comes in, because it can't represent even -1. Meaning it can't even represent -1. Okay. Yeah, makes sense. We just do .data. Oh, get compile time bounds checking. Okay. Makes sense. It just checks that, hey, is the index less than the size? Done. If it is, then we're good. Well, and not in greater than 0, I guess. The standard get the thing? Oh. Oh, we passed in a non-type template parameter, huh? Okay. So it's like template int x, and then in a specialization it uses x for whatever. Or, well, specifically it says assert or static assert that x is greater than or equal to 0 and less than the size. At is only at runtime. Parameters can't be made it. I mean, we could use non-type template parameters. That's on the right, it seems like. So if we're trying to pass it to a function, I guess we're not trying to. We're trying to get the value. We pass it as a, well, actually, yeah, that's the point. Standard get is a function, and it takes, I guess, an implicit object. Well, not even an implicit object. It just takes a, it's like having standard print something or something and something dot print. But this time we say get, and we pass in the types or the index we're trying to get, and then it checks to make sure that that's valid, and then returns the value. Standard get, okay. Oh, I need more music. Okay. Instead of trying to get the value and getting some undefined shit or getting an assert at runtime for .at, then we can index this guy. Already heard this one. Excuse me. Yeah. Well, it'd have to be 2. I assume 4? Or sorry, 2? Yeah. We check something real quick. No, I'll do it tomorrow. Inside the implementation, yeah, it makes sense that there's a yeah, I mean, I assume it looks probably something like wait, that was really good. I like this Armored Core music. This is good. I'm gonna save that. Like faster stuff. This is too slow. Come on. So there's nothing here, but what we could have is a function called get, and what it is. Oh, I guess it is a class template, huh? Because we get whatever. Well, actually, hold. Yeah, we get whatever the value is. Okay. Oops. Well, see if I can get this off. Nice. Let's see. It's and static assert is already included in base C++. Uh-oh. This is actually okay. Well, actually, no, this is wrong. Do we care about this though, actually? I guess we do, right? The problem here is that X is, well, but we're not specifying the length of the array in the get. It's interpreting that. So how is this working? Because what it's doing is it's saying static assert that array size is greater than X, or really that X is less than array size. And once true, then it's returning I mean, what if we did that, huh? Seems like that makes more sense because then type deduction is letting it happen. Or is it to array where we're letting it specify the size? No, it's not to array because, well, it could be this thing that's initialized with to array. Yeah, but we don't know what value is going to go there. I'm going to say this, I'm going to say get it instead in this case. Standard array, list, and it's 0, or well, it's 1, 2, and 3. And we're going to do standard get it, list. Uh-oh. Oh, wait, hold. I don't even want to see the errors here. Actually, I don't want to read that. All right, cool. So I'm going to do standard get it. And we're going to say int 2. Actually, we don't need type name t either. Fuck, what's happening here? Oh, hold. Fuck, I guess we do. Oh, wait, yeah, we do. That's fine. What the fuck is there a template there? Oh, well, the problem is now it's, well, the problem is we'd have to specify this now. Say it's expecting a type now. Oh, auto. There it is. Fuck. What if we said, oh, well, true, hold. What's not evaluating? Line 8. Well, So that part's fine. It actually is the array size? I'm surprised. Well, I mean, you would think it would deduce this and create a specialization for a standard array specifically, no? Oh, you know, it might be converting the standard array to something else, though. Oh! Array isn't, okay. Still, even then, really? I mean, this guy's const expression, we're passing the list in, but we're treating it as const reference anyway, so it should have been fine. If we're treating it as a const reference, we aren't changing anything. We're asserting that the length that we're passing in, well, the index we're passing in is less than the size. But for some reason, the array isn't evaluating at compile time. Alright, I'm not too worried. Let's find out. Say this guy. It takes a standard size t, but I'm also not explicitly saying the type. And I'm also not saying whatever this n is. Oh, is it because, well, it's not optional, it doesn't say. Oh, wait. What is this I here? I don't know what this I is. I get that, hey, this is integer. I get this is the length. I get that this is the name of the array. Hmm. Okay, lady. Yeah, I don't know how this is actually implemented. Template arguments must be const expression. It has to be called with const expression indices, meaning that this is the index. Well, yeah, because that's just a non-type template parameter. Well, this is not a, well, okay, template argument, sure, but really this is a non-type template parameter, or a non-type template argument. Print the length, and then use that, and that to print it at element 1. Okay. We're doing 1. Oh yeah, and excuse me, I prefer the member instead of standard size. It's just longer. I mean, it would make sense that we're going to pass him by const reference, right? There it is. Pass just like any other object. Expensive because it's a class type and it's holding a bunch of it could be holding a bunch of shit. And actually, let's just find out what the minimum size is anyways. I need cool. Okay, so it does need to know. All right. So the minimum size, even with nothing, is 4 bytes. What about 1? What about 3? Oh. 2? Wait, 2 is 8. 1 is 4. Okay, so the minimum is 4, and then there's still 4, and then it goes up each time. Okay. So this is, I'm guessing, 20. What? These lyrics. Oh. Both the element and the array length are type of the are part of the object's information. Well, yeah, because if we had a function and it was receiving a standard array, I mean, I guess it would need the size and the type, right? Type and the size. Cool. Okay, we could do templates. All right. This is good guitar. Better syntax. There it is. Hence the A. Class template argument deduction, bucko. Use some template action. Okay. I remember this music. Holy shit. Let's go back to that one playlist. It was pretty damn good. Bro, please. Sure. Doing it with a temporary. But it's an L value, which is okay here because, well, it's an R value, and that's okay because this is a const reference, and we can get our L value. Const references can bind to R values. We could also do print. We could also create a standard array. Standard array. We could do this too. We could also do and actually that's cool because it works with the arguments, so we don't have to pass it the stuff. I was thinking about getting the type, standard type. Is it type of, what is it? X.type? There was something I thought, I guess not, maybe not. I thought there was something that would return the type. So we're gonna get all of them. Boom, boom, boom. Cool. Nothing const expression because we're using standard character output. How did I even make that? I don't remember. Excuse me. Oh, a non-type input parameter. Makes sense. Oh wow, that's pretty good. Getting muscle memory. I didn't even think about that. I'm actually starting to become shit instead of being really bad. I'm becoming a little better. Bro, I swear he's saying I'm in your mouth. Oh, true. Well, mine works without having to explicitly index it, but you could also do. Sure, I mean, you could do a loop. But then this is only printing the first of each 9.1 and 1.2. Yep, and it's going to create separate template, or well, separate template functions. This is a function template, but it will generate separate template functions. So functions, instantiations, specializations automatically, made by the compiler, instantiations that each print the first index of the guy. So first it makes sure that the length of this whole guy isn't 0, because if it's 0, we can't index it at all because there are no values in the array. It's a 0 length array. Is it? Not 0 length. I don't know about this. This is really going to hit or it's really bad. I can't tell. Yep. Yep. Uh-oh. Well, we get some narrowing? Or maybe non-type templates don't match. Okay. Or don't do conversions. Oh shit, it'll just find wait, are you sure? Are you sure, Bucko? Oh, that's because I did. No, I totally didn't, buddy. Is this true? I mean, I believe that it should be a standard size T. And we don't put it in there because one, this is easier. Class template argument deduction. And two, integers are compile time and they can convert without issue because the compiler is the one doing the converting. Are you sure, Bucko? I'm not sure that's totally true. Oh, because it's called array. That's why it's standard array. Gotcha. That way when we call it, where we get it, 5 integers. And the point is it's taking this template type parameter and this template this non-type template parameter, or I'm going to say type template parameter and a non-type template parameter, and it is instantiating a function version that takes that type template parameter and that non-type template parameter. So an integer is the type, and 5 is the non-type, the value, or the number. Yep. Makes sense. It's possible to do that because what are we saying? To template only one of the two. Oh. Meaning, we could leave one as integer and then specify the size. Or we could leave the type so that it only accepts, or leave the length so that we specify int, but it only accepts ones of 5. Like we could say, so we'll say, or we could just say array x with 1, 2, 3, 4. Oops. And then we'll just do, sure, we could do that. Boom, boom. We're going to get a redefinition issue here, so let's... Cool, this is all fine, but then watch. Last one is cool because of the size, but here, nothing matches. Because this guy has length of 4. No, sir. But now if we create them with different types, works. Why does it work? Because this guy has, well, let's see. Oh, there's another gnat. I can't believe it. I should have put the second thing of trash out. I forgot I had 2 things to put out. Well, GG. Template. Well, it's going to take this and see, hey, you are passing in an array of length 5 and it's of type integer. Okay, cool. Integer matches. And it's going to deduce the length to be 5 for this guy here, this template parameter. Well, this template parameter, which specifically is a non-type template parameter because it's not a type parameter, it's a non-type. It's a value parameter, an integer. So, or a size t, an unsigned long. And in here, 1, 2, 3, 4, 5, 6. Womp. Wait, oh, it's not womp because we only care about the size here. Well, this is restricted to integers only. So this is pass int standard array or standard array int only. Doesn't care about the length though. But here, even though the length is okay, 5 elements, we have double. Won't find a match because there's no way it can generate a version for double. The type of a non-type template parameter so that you can use it in this. Yeah, I did this earlier. Yeah, I mean, for example, let's see. Well, let's just say, only of type int only accepts integer. Doesn't give a shit about the size though. So we could have standard array x, sure, 1, 2, 3, 4, 5, 6. And then standard array y, 1, 2. And then print array x, print array y. And then standard array z, 1.2. Only one element. Uh-oh. Uh-oh. We're cool, but we're not printing them yet. But now we do print array z. Uh-oh. This guy should be named something like print int array or print array of ints. Something like that. If you were actually going to leave it. Maybe we want to handle them different. So we could say, we could do, hold. Oh. Okay. So we have this now. But we could make a specialization where we say template, this guy's fine. Void print array. Yep, and it already sees which specialization or which function template it's going to be not overloading but creating a specialization of. And in this case we want one for doubles, and then we don't care about the other. Well, if we're making a specialization, I think we have to specify everything. Let's try though. Well, let's try first double and 5. Okay. And then we're going to say const standard array of double. 5 is the length array. And it doesn't do shit. Hold. And we could here just say maybe unused. But if we remove 5. Oh shit. Wait, this is really good. You know what? I'm saving it. What if we say auto? Uh-oh. Uh-oh. Or what if we do auto size still? And then put in size. Nope, because the specialization needs to know, I guess, huh? What if you say auto size? Well, nah, it doesn't like it. Oh, nah, it's not happy. Well. Oh, hold. Illegal. And that wouldn't work either. Oh, it even has the same, it has the same values here. Because we're saying this is a specialization, this is where I'm plugging it in. It's a little redundant, but okay. Maybe it's more readable though, I don't know. But yeah, sure. You could put in auto up in there, that's fine. That's what we did in the very, very, very beginning, right? It's literally what we did. Well, that's what I did here. In the parameter declaration, yeah. That way, once the template functions, the instantiations have been created, then there's no more deduction. It just matches straight. Static assert on the array length. Okay, so we have standard array, and we say print an element. Well, what we want to do is, in this case, we want to make sure that it is that length. So we could just do a static assert. We did this earlier. We static assert that whatever the index we're passing is or that the index is, well, if we're printing element 3, what we should do really is just say, hey, static assert that 3 is less than standard array, well, array.size. Yeah, we already looked at this. Yeah, we only have one that goes from 0 to 1, not 2, nor 3. Invalid undefined behavior. And we're not doing at or get, so we have no bounds checking. I mean, you could do get. Yeah, get will do bounds checking. Or we could do a static assert. It says one solution. He's going to say but here. Oh, never mind. It's just an alternative. Okay. I was going to say I couldn't think of anything that is different here. Yeah, it makes sense. Yeah, because we get these at compile time. So it's not, oh, we have a standard vector and we have to actually run the program to figure out whether it happens. Instead, we could just compile and then see, oh shit, he's out of bounds, bucko. Right? Well, what do we even want here? I mean, if we want the behavior to be static, we want the same behavior no matter what. Always the third index, we have to make sure that it's available here or have some sort of early return. And if we're doing an assert, well, I guess static assert won't get, well, if you have a static assert, your shit can't compile, so you can't even make it run. It's not like runtime where it gets removed if you do a release build. I'm gonna eat some chips. I'm a fat fuck. Well, the point is that the template parameters that are required in standard vectors, or standard array, sorry, are compile time constants. So we can do things with them at compile time. But we already found the same shit earlier with size, where we made sure that the size is good. We could do two things. We could say, hey, one, assert that the size is proper, or just use get. And if we use standard get, then if we're accessing out of bounds, issue, compile error. What would we even choose? Assert versus that? I mean, it asserts, it'll say, hey, got him. Fucking Nat. I mean, it would just say it failed and then boom. What would it say for the static assert? I don't know if I've actually done that for some reason. What is this shit? We could just say womp. Is it just bugging out? I mean, we could just, what if we instead did static assert that x size is greater than or equal to, well, is greater than 3. That part fails. But when we're calling standard get, what happens if we do it up here? Give me same issue. Let's just reboot. I'm not sure why it's not giving me the error. Doesn't say. Can't run it either. Okay, well. But instead of this, we could say, we could get runtime here. Well, we already did static assert. It just says that the assertion failed. Well, will it say the condition though for a static assertion? We do static assert that array's size is greater than or equal to 4 or is greater than 3. That way we can use it. In this case, okay. Couldn't tell if there was a bug in my shirt or not. Going schizo mode because I'm killing spiders like every day. Oh wow, nice. It does give you that. Good to know. Does it print like this too? No, it doesn't. Okay. I figured not. Couple more chip. It's not as good as 1A, but it's pretty good. Just gotta get the freaking spit off. All right. Good to get, but the error is funk. You're missing another. Oh, never mind. Never mind. We see, hey, array, type integer 5, print, boom, boom, boom. 3 is valid. We have size 5. We can print. Well, this is the index, so size 5, so up to 4. So 3 is valid. Or we could say size 5, minus 1 is 4, 3 is less than that or equal to, so we're good. Array 2, size 2. Passing, okay. Integer 2. Integer 2. Array is being used by reference, passed by reference. Get the third element, 0, 1. Uh-oh. No, sir, we don't have a 3 index. Nor a 2. Makes sense. Once it sees this, it instantiates a version with this guy. Well, I guess the point is it actually will instantiate it with this version. Inside the body is that. Or hold. When it reaches the call for 1, it will create it with int 5, but then it will create another one for int 2. We could also just pass it and say, hey, is the length... Well, actually, we don't need the size, huh? That's true. We don't need the size. We could just use the size we're accepting. But if we're not using that, then we don't necessarily have to. Well, I guess we would, right? Where's my redundancy at, huh? This should just be size. This is redundant. Boom. Scary. Yep. Yeah, that's what I did. Bro. Oh. No, never mind. I'm not sure why that one error was invisible. Makes sense. Do we get move semantics? Move semantics? Move semantics? Move semantics? Never mind. Guess we don't. Uh-oh. Let's do 30 push-ups real quick. I want to do one arms again at some point, but 30. We'll just do 30. Give me an excuse to eat these chips. Full? Okay. 30 perfectly clean. Beautiful. 1, 2, 3, 4. Five. Oh, I'm such a wimp, dude. Alright, 15 more. Ten more. Oh, 5 more. Oh, done. Whew. Turning a standard array. Actually, let me finish this chips real fast. Mm-hmm. I mean, seems like it isn't mega uncommon. It's a piece of chip. I don't think it's mega uncommon for us to return classes by value. Like if we're getting a standard string from the user, we're creating a fucking standard string, assigning it the user's output. So we've assigned value to it once. But then we're returning it. Oh, that's the point. For standard vector, we can return and we can use move semantics. For classes, I mean, there are copy semantics to remove unnecessary copies. So for example, if we had a function that we call a function and we pass it by two references, we pass it two separate classes by reference and it adds them together. So two vectors, for example, but not standard vectors, just two structs, whatever, and each one has three, an x, y, and z, three integers. Or maybe it's template types, so maybe it's adding a double or a float or whatever. Int, a short, a long, whatever. But it returns a standard or a class, whatever that class is. If we pass the two references and then we copied those to two objects and then we returned the sum of those, I believe the compiler would elide those copy constructor calls. So it would remove those and not create those additional objects and simply add the values where they are in memory and pull them from here and here, instead of pulling one from one address and copying, pulling another and copying, and then summing and returning to copy yet again. Instead, it would just do add and assign that value somewhere. That's it. And I guess technically maybe it's creating a temporary and assigning it that value, and then it's assigning that value again. So we're assigning a class value twice. Maybe. But maybe it doesn't even do that. Maybe it actually elides that too. I don't know how to manually do move semantics for regular classes, so it seems like we do return by value, but usually we don't create a class. Usually we create a class, but we don't call a function that returns it by value. I mean, I guess it wouldn't necessarily be terrible, right? Because we either call one constructor or another. Well, no, it is bad, because if we're returning the class, that means we have created the class and then we're copying it. It just depends on how expensive that is. I think the cost of copying a class from A to B or to another place in memory has to be similarly expensive to just initializing the class in the first place. Because if we say that a class has these two members and I initialize one and I initialize another, well, if I'm initializing another class with this class, or with a class object with this class object, I mean, really what we're doing is we're member-wise assigning these guys via the copy constructor. So they're probably the same. So if we create a temporary and assign it value, and then return it and copy it, then we have two things going on. So it seems like when you want a class object, just make the class object. Okay. Like maybe we create a standard array and we initialize it with, well, if we called a function that returned a standard array, and in the beginning of the function it created a standard array and used pushback to keep on adding, well, it can't because it's a standard vector. It can't be resized. Never mind. I mean, maybe it's a standard vector and somehow that gets converted to a standard array and then returned. I don't know. Another nat. This is pretty damn good. What the hell? Whose vocals? I didn't get it. It's not move capable. GG. The elements inside will be moved if they're move capable and copied otherwise. The array is not huge. Okay, I think the fundamental types are the ones that can be moved. Well, I guess the fundamentals are the cheap, but then standard string, for example, can be moved. In such cases, a copy will be made. Because if we assume that, okay, there's some sort of cost to find this piece of memory and put values there, but the cost is moving the values there, so it's not very, I mean, it shouldn't be expensive. But this assumes that the type here is movable, because this might generate, let's pretend that doubles are not movable while integers are. We create a variable, or we create a standard array of 1,000 integers, so integer 1,000, initialize it with input array, and it returns the standard array that is copied into it. But maybe you do that with a thousand float version too. So float 1,000. Well, now these guys in the inside are not movable. So in one case, you're creating another array and you're moving the values into it instead of copying them. You're just assigning ownership from this temporary copy here. We're moving these values in here of this type to this guy, array. But if it's float, then we have to copy them. So this is only safe in some tests here, depending on the type, because of the element type. Okay. Oops. All right, so we'll do that. That's it for now. One more.